You were on it, baby.
Yeah, I mean, I was in a rut and I was going.
Nice. Well, so what are you going to work on, Joe?
I am going to. Ooh, boy, that Southern twang came out all of a sudden. My bad.
Nice.
Good night.
That's all right.
It's yeah, it's late enough that's happening. Welcome back to the Aviation RC Noob Podcast. You found us. My name is Joe.
And I'm Matt.
We're here to be with you along your journey and to share our experiences in RC aviation. If you have any questions, thoughts, or want to share a flight story, hit us up at aviationrcnoob@gmail.com. Now, buckle in. Let's take off.
All right, welcome back. It's episode 31. We're going to talk about designing airplanes. So, Joe, we were talking about a couple different things, and I know you wanted to do a little bit of housekeeping before we get a little deeper into this.
I did. So sort of as we were getting ready for this episode, I always like to go through and check our emails and make sure that nothing came in that we had missed. And I saw something from the website come in. It's our form manager for the contact us form, essentially. It was saying that we had so many of the forms filled out and sent in, and I'm not getting any of those, or we're not getting any of them. So I just want to say, if you have filled out the form, the contact us form, and you haven't heard from us, or you haven't heard it discussed on the air,
we're sorry.
Then, yeah, we're sorry. It may not have come through.
Right, and if you want to reach out again and do it directly through the emails that we list at the end of the episode.
Mm-hmm. And you can email, like Matthew said, you email us directly, aviationrcnoob@gmail.com, Matthew at aviationrcnoob.com, and Joe at aviationrcnoob.com.
Mm-hmm.
But it's saying that it seems to be saying that there's versions of that form that have been completed that I hadn't seen, so I wanted to make sure that if somebody is filling these forms out and we're missing them, that we can let y'all know. So
absolutely.
The other thing I want to say, as just kind of finish up housekeeping, is we said on the tail end of last episode, but figured bring it up on the front end of this one.
Mm-hmm.
If you guys are enjoying the show week to week, or every 2 week to every 2 week, or every 3 week, as it was for the last episode. Sorry about that.
or if you're binge listening every couple hours.
There you go. Then share us with a friend. If you're enjoying us, chances are you know somebody who would enjoy us as well.
Mm-hmm.
So yeah. And speaking of the contacting us form, Matthew, we did have a comment, a question come in.
Excellent.
From a Leroy Peterson. He said, "Hey guys, just got done listening to the Flight Fest video. So I assume Flight Fest episode. I knew I would regret not going. Now it is worse. Thanks for that. Just kidding."
Happy to help.
Hate you ended up missing that, but maybe next time we'll be able to link up. You'll be able to come. We'll all be there. We can meet up.
Yeah, it'd be good.
So he says, "I would like to know how to make a foam board plane using a 3-view from a full-size plane." Well, Leroy, thank you for that. And actually, when your comment came in, I talked to Matt and I said, I think we got our next episode topic.
Mm-hmm. Yeah, I mean, we have a small list of things, and I think looking to take a quick break from, I'll call it our regularly scheduled program. And, Joe and I were kind of thinking what might be a best idea. And you really kind of hit it on the head. Something we've definitely been considering as part of this series is to talk about making airplanes.
Mm-hmm.
And so,
or specifically how to go about designing them, because I've not got any experience with that.
That's a lie. That's a bold-faced lie.
Okay.
You designed an airplane, the first thing, almost the second plane you built.
All right. Well, let's go ahead and get our flying and building.
Yeah, let's go to that.
And then we can dive into that.
Yeah, we'll dive into that in a little while. I'm coming back to it.
Okay, fair enough. So flying and building, not a whole lot on my end again. par the course at this point. I've got everything unloaded from Flight Fest at this point, but last night sometime, good Lord, time is just blending together.
That's what happens when you're busy.
Saturday. It was Saturday.
Okay, yeah.
Good night.
Yeah.
And it's Tuesday. Boy, I'm really messed up. Saturday, I was hanging out in the garage, and I got the Corsair repaired up.
Okay.
The wing had actually kind of delaminated a bit, so the top was coming from the bottom, where it come unglued, and the fuselage, so the engine cowl had actually started to rip from the bottom up to the barbecue skewer holes.
Okay, was that the skin or the actual foam too?
No, the actual foam had ripped too.
Okay.
From that nose down impact, the last one that it took.
Yeah, they'll do that.
Yeah, so it was actually starting to tear upward, so that cowl had some up and down deflection if you worked at it. So that was going to be a problem. So I went ahead and what I ended up doing with that was just taking some short, thin bits of foam board, and just laying the glue to it and wrapping my finger, which was a pain to get into because of where it was. The box of the power pod mount is also like right there, so it was tight fit. But I got in there, just like laid the glue to it and reinforced that cowl area and held the cowl in position.
Okay,
so
good.
Hopefully that won't be a problem.
Okay.
The servos.
Did you fix the delamination? I wanted to make a comment about. That's one of the things that's the downfall of using Dollar Tree foam board, right? It's not, the paper is barely on, which is a blessing and a curse all at the same time. One of the things, as a reminder, one of the things Flight Test recommends is you basically glue up all the edges really quick. Just do a quick smear of hot glue while it's hot along all the edges, and it's going to take much longer to delaminate. So it's a lot more time than I want to spend when I'm building these, but if it's a plane you like and you want to keep together, that's an option.
Somehow I missed that tip.
It's in some of the older videos. I don't think they mention it as often, and I know the new Master Series stuff, they don't talk about it at all.
Okay.
Not much.
Well, so what I used the wrong term when I said it was delaminating. It was that some of the gluing from the foam board to the wing spar, from the bottom wing part to the top wing part, had popped loose.
The clamshell opened up.
Yeah, there we go. That's a much better statement. So there was some re-gluing of that and trying to get that re-secured. In fact, my landing gear, as part of that impact or that last landing, my landing gear was actually starting to try to bust through the bottom of the wing. So there was gluing a popsicle stick from wing spar to wing spar, one of the fat popsicle sticks, and then punching two holes on either side of that so I could then wrap a zip tie around the popsicle stick, but then would loop into the wing to get underneath the landing gear to hold it to the popsicle stick. Tried to divert that load to the wing spars instead of just where it can pop right through I'll try to remember to take a picture so I can upload that, so I can say, in the show notes, look at the show notes, because that may not have been very clear as to what I was saying. But
I thought it was clear enough. But yeah, it's basically reinforcing where the landing gear sits on the wing so it doesn't bust through the bottom material.
Right, and the difficulty of that is that because I couldn't get inside the wing, so I'm trying to reinforce, or instead of being able to put the popsicle stick behind, if you will, the landing gear wire, so that when the wire takes a load, it's put directly onto the popsicle stick. I'm having to try to grab that as a pulling mechanism. So when the landing gear gets pressure, that zip tie is there trying to keep it pulled up against the popsicle stick. It's just, instead of being pressed, it's being pulled. I don't know how well it's going to work. But.
Sometimes when you hit the landing gear, it's basically trying to leverage at the bend to pull the outer edge off your plane. And so you want to try to keep, that's half the reason you don't want to have it push through at the bend. and you don't want to have a pull off at the other end. So yeah, it's zip ties work wonders. So I'm hoping that'll help you keep your landing gear on.
Mm-hmm. And I'm
fix.
I don't know if I'm gonna fly that Corsair again, honestly. So I did a taxi test with it in the driveway, and I had to straighten one of the wheels because it was a bit cocked compared to the other. So I've kind of got where I can taxi it straight, but where the landing gear's mounted, I kicked it forward a bit more so that the wheels were farther forward of center of gravity, so the plane didn't immediately want to, as soon as it started moving, flip over forward of the wheels. But I don't know if I'm gonna fly that Corsair's now got me kind of nervous because every flight I've had with it, or every time I've taken it flying, I've crashed it, and it's and maybe it's just the warbird nature of it. I don't feel like the Spitfire flew that rough, or it could be the gull wing shape that I'm not accustomed to. It is a heavier plane. Yeah. I don't know.
It's a different bird, and I haven't built mine yet, so I don't have any expertise to lend to that.
I don't know. So I'm probably still going to fly it, but another of my concern now is because I have the landing gear on it, I've really restricted where I'm comfortable landing.
Right. I didn't even think about that. I figured, well, you got landing gear, it's going to make it easier. And then I'm like, when you mentioned that to me earlier, I was thinking, oh yeah, right. On kind of rough grass, that landing gear actually makes it harder to land.
Yeah. And not having landed on landing gear really yet, I'm probably going to be aiming strictly for pavement, concrete, the hard, smooth surface to land on. So,
or a freshly mown soccer field. Freshly mown soccer field will do well for you.
I used to play on a soccer field. There's a lot of little divots in that soccer field you don't see from the side.
Just remember, once the wheels are down, you do elevator full up, and it'll kick the tail to the ground.
Yeah,
and that's how you keep from tipping over. I mean, that's how we do it in most airplanes, honestly, full size and otherwise.
And then just kind of rounding mine out. While I know I've got the 7 that's still needing to be built, I have jumped ahead of that process, and I opened up the Sea Duck and started working on it. Nice. So the reasoning behind that is I have a gentleman that I work with once a month that I'll be going down to see him. It's coming up in about 2 weeks, and he's interested in flying or seeing one of my planes fly, and we talked about the possibility of doing a water takeoff and landing. So the only bird that I got that could do that right now is the Duck, so I got to get it built.
Okay.
And I don't think I mentioned the Duck in the last episode. We were talking about Flight Fest, but I picked up the Duck while we were at Flight Fest.
Yeah, it's a good pick. I saw you get them, like, ooh, nice work.
Oh yeah,
yeah. I know you've been eyeing that up, and you've been like, Matt, get it cut for me already. With the needle cutter. He's not trying to put me to slave labor or anything.
And then
it's a good pick either way.
Yeah. And then last, real quick, I think I'm gonna go ahead sometime soon. I gotta buy at least one engine. I'll probably just go ahead and buy 2 motors for the Duck. CPAC kind of equivalents, and then along with that purchase, I'll probably go ahead and buy the FT Aura light board.
Ooh.
And if you don't know, and for anyone who doesn't know, if you happen to be signed up for the Flight Test Community Association, I signed up as air crew, so I don't know what the ground crew got as part of their email, but I know this month they had a $10 off the Aura board in the Flight Test store. So
okay, you know what? I've actually looked at trying to join that, and I can't seem to find it. But we can talk about that after outside. But yeah, that is one of the perks. They're trying to basically have a good reason to be part of that community. It's
Hmm.
it's a good community. All the people I
So
know
that's what I got.
are
What you
good
been up to?
folks. Me? I've been up to a lot of different things, but nothing super significant. I flew the Piranha, and I ended up crashing it. Actually, I ended up torquing it over and nosing straight in. And all I can say is, thankfully, it's made of far more resilient material than what other planes are made from. I think it's a type of EPP, kind of a rubberized plastic, or rubberized foam.
Okay.
Because it wasn't going terribly fast, but it is a heavy plane. Not entirely, but there's a 6S battery in it, so that's pretty heavy.
Okay. I guess I can see it. It just didn't. I don't know. I still hadn't seen one up close. I've only seen it from a distance, so I don't know how big this thing is.
It's probably about the 30 to 36 inches by maybe 40 inches.
Really?
It's a triangle, basically.
Okay.
I mean, it's not crazy big, but it's again, it's got a 6S in it and a pretty honking motor to go 120 miles an hour with a 6.5 inch prop. So what ended up happening was I did not engage the launch assist, and I cranked it and just sort of like tossed it out of my hand. So normally what guys do, I guess, if they're going to launch that kind of plane, they get it up to speed and they wing it, literally grab it by the wing and hurl it like a discus almost, and kind of zing it out there. And at that point, it's already got enough speed to start getting lift evenly across the wings, so that the torque factor isn't huge and they can get their hands. And so what happened by the time I got my hands on the sticks, it was literally inverted. And so when I panicked, I ended up tanking it into the dirt.
Yeah, I can see how that could happen.
Yep. Yeah. And I'm not sure. I'm trying to remember. So yeah, whatever I thought was going to be engaged was either engaged and actually working actively against me because it's like, oh, you don't want to turn that fast. I'm like, yes, I do. Or it wasn't engaged at all, which is why I torqued over. I'm still trying to figure out why that didn't engage. I tried to redo it this week. So basically what I did is I used hot water to re-expand the foam, and it kind of got rid of a lot of the crunch that happened in the nose. But I mean, really, it's almost completely intact. The battery tray balsa ply is a little cracked. So that's probably about the biggest damage. That, and the nose is a little turned up. But like I said, I put some hot water and I put it in some like steaming water, and like I said, it took care of most of the damage. Kind of restored it to its original status. So that's pretty cool.
I'm glad for that because that was not a cheap plane to go and grab.
It also wasn't for a was it super ARF? So almost absolutely ready to fly. Like you don't have to put in servos, already done. The Aura board's already set up and ready to go. Like all you have to do is put your receiver in and put a battery in and you're ready to fly. So, for all that stuff, it really is, I think it's inexpensive because again, most planes that size with that kind of motor setup and all that stuff tend to be around $300. So they're much further under that. So, I'm glad it didn't go to pieces on my second try. And it will fly again. I pulled out the old Fogey, and I flew that for a little while, and I realized that the elevator the paper was becoming a little delaminated, so it was a bit tricky to fly. It was not a hands-off experience like I was hoping, but it was still a great gentle fly, especially with a big wing. And now that it's had time to relax from all the warping, from all the moisture from earlier, it's actually pretty straight and even now. And so,
that's good.
Except for the wingtips, which gives it some dihedral. And so it flies really well, generally speaking. And I just went tonight and fixed the elevator issue. So it should fly really well. I'm looking forward to bringing that again. Matter of fact, some of the guys in the field like, is that foam board again? I'm like, yeah, that's foam board. I'm making a lot of planes. He's like, whoa, holy cow. Is that only one layer of foam board? I'm like, well, there's giant 36-inch barbecue skewers, basically, used for s'mores in there. So that's really giving most of the strength. He's like, "Are you sure that's?" I'm like, "It'll be fine." So, and it was. Then I pulled out, I've been building a parasite fighter. So it's like basically a fighter jet, but it was designed to actually have like 10 of them inside a Boeing 747 as a mobile aircraft carrier, like an air supported aircraft carrier. And it would basically lower these things out of the jet in the air, out of the airliner, and send them off to go do fighting, and then come up behind it and underneath it, and then be caught by an arm in there and brought back into the aircraft.
What?
Carrier. Yeah. It's an experimental plane in the 1950s, I guess, as a Cold War long range, accessory to kind of extend our threat range.
And reiterate, Kitty Hawk was 1911, right?
Yeah.
Okay.
No, it was actually 1904. It's 1904. Sorry. So it's at the very turn of the century.
Okay. Wow. I'm bad.
That's okay.
But
shame on you. But
less than 50 years, and these people are trying to
put planes. Well, we've been trying to put planes on other planes for a while.
Oh man. Okay.
And it was Boeing that came up with this concept idea, and it's a white paper. You can look it up online. It's a real deal. America wanted to see what kind of feasibility. So they have like 6 or 4 variations on that parasite fighter jet thing. And it's like, the diameter or the wingspan is like 12 feet. You know what I mean? It's really small. So I've got it here. I built one for a 30 millimeter EDF, which didn't have enough oomph. So I decided I'd scale it up just a little bit and make it a 50 millimeter. And if that works, then the Boeing 747 that these things would fit in would be massive. I'm not sure. Anyway, the idea was to make a 747 and fit these 30 millimeter ones in, and then I guess just have them glide, or I don't know what. I hadn't thought that far through. I figured let's make the jet and see if it flies first. So I've been working on that, and it's just I'm taking it easy. I'm not going hightailing it or anything like that on it. And then while I was kind of in the midst of building that and taking my time, somewhere in those days of doing that, a project came in that I had almost forgot that I purchased, and it's a microplane called it's from Minimum RC. It's called the Star Voyager, but basically I call it the flying boat because that's what it is. It's actually like a galleon, like from the Pirates, and it has like sails. It looks like sails on top, and 2 of them are like wings. It's almost like so it's essentially a biplane, and they put like a little 0820 brushed motor with a 4 or 5 inch propeller. Nothing crazy big, and the whole thing all up weight is 32 grams without the battery, and it can haul a 150 milliamp battery or a 450 milliamp battery at 15 grams there. Almost 50% add on the weight for that, but it seems to fly just fine. And honestly, it's a little finicky to get up in the air, like all my flights, I guess, maybe because it didn't come with any instructions. So I don't know. I make it, I think it's like the equivalent of, somebody gives you a kit that's like a paper castle, and somebody says, well, just build it. And like, there's no instructions on how. It sort of intuitively goes together. There's a couple pictures, should be okay. And really the biggest thing, I think, where the instructions would have been helpful, and I went to their website and they didn't have anything, and I reached out in the chat that comes up and there's no response. So if you buy it, it's kind of a discontinued from their product line, but it's all over like the Banggood and AliExpress and all the China wholesaler kind of places. So I don't know, it's neat. It's pretty interesting. And you can get the kit that comes with the motor and the servos. And as long as you have a micro RX, micro receiver, and a really small battery. So anything that would come with like a little micro quad or anything like that would probably work. Again, 150 milliamp to 450. I don't know if I'd put anything more than that, but it seemed to fly just fine. It has 2 control surfaces, had an elevator and a rudder. And I think I overglued the rudder, so it made control a little wonky. But that's honestly relatively easy fixed.
Overglued in that what you got too much glue in the fold.
It's so I glued too much on the bottom half, and the top half I guess didn't get enough glue. So as I was trying to turn, that's where the top half is where the control arm is. So I'm rotating the part that's no longer glued. And so it's kind of catching as it rotates. So it's like bending a little and trying to rotate, but it can't because it's bent. And so I just need to reglue that part. And then that'll probably be fine. And I just know that it's giving a little resistance as opposed to being completely free because, again, I used a little bit too much glue on the lower parts. There's a bunch of fixes I could do. Instead, just basically disconnect it and redo it with glue, with tape. I could make little eyelets or find a tube and a small wire to glue so that they're free moving completely. Either way, it'll work. It's a neat little flyer. And again, for 150 milliamp battery, it lasted, I think, 4 minutes flying around the cul-de-sac. So it's not like it was, and I was flying over top of a bunch of neighbors for a little while, I was in the neighborhood. So there's in the street over a couple neighbors who are looking, I'm like, oh, what's that? That's pretty cool. Cause it weighs 32 grams. Dripping wet, it's 40 grams. I mean, if it hits somebody, you can't even possibly hurt somebody with it. I really would have a hard time with that.
It's just so much braver than I am.
Or just maybe more addicted to flying. I don't know. I was excited. I was excited to get it done and just see if it could fly. And I have a couple of videos, and the videos, I may put a link in there. The first launch, after I first made it, I launched it. It turned left and went right into the bush. And
nice.
And it kind of dislodged a couple of things. I'm like, okay, well, let me reglue that. And then when I went back out again, I decided I'll get all the video equipment out. And the first launch was pretty much straight into the concrete. Yep. Okay. So it required a little bit of tape and a little bit of glue and a couple of minutes. And everything was kind of back in shape for the most part. And it's interesting because the main masts are a little wobbly. However, the lift happens from the wings, and most of the plane hangs below that, like a hang glider kind of. So it's a lot more stable than it appears it's going to be. Like once you launch it, it pretty much chills out.
Where's the motor mounted?
It's mounted right in front of the bottom wing, which is an inch or about 2.5 inches above the main deck of the boat.
Okay. I was worried it was going to be mounted on the boat somehow or on the actual main body of the boat, and then you're going to have drag issues with the wings one way or another. So
yeah, right. I thought I was trying to figure out when I first looked at it, like where in the world's a motor? So yeah, it'll be interesting to see how that goes. So I'm scaling that up. I've already got the plan set up and printed out. So I'm going to give it a try to print out a bigger version and see how that goes. I imagine that'll work really well with an APAC or an FPAC motor. It'll still be gentle and slow, which is what I was looking for. And then the last thing is I pulled out an old project. As a matter of fact, it was more of an effort to clean out planes in the various parts of my house. I decided to pull the 2 planes that are in my bathroom, the flying submarines, the Russian flying submarine. And I filled up my tub and finally did the sink test, which is the reason why they were in the bathtub in the first place, or in the bathroom in the first place. So I filled up the tub. I brought in a bunch of soup cans, and I started just dropped it in there, and it sat really pretty on the water, which was great. So that's always nice to see that it'll do pretty good. And then I started loading it up. And I used all the soup cans that I had in there, and I didn't fully submerge it, but it was incredibly unstable by the time I got it to the point it was just the copula sticking out, which was fine with me. I'm like, well, that's if I get to that point and I can sink it and like zoom around the water, I'll be okay. And yeah, it was like 3 kilograms of weight. So
Wow.
what is that? Like 7 pounds? Is that?
Tell you what, keep
Two.
talking and I'll let you know in a second.
Okay.
You said 7 kilograms?
No, 3.3 kilograms.
3.3 kilogram?
Mm-hmm. Right. On top of the, and it has like, I think the plane is
Look
originally
at you,
250.
7.27 pounds.
Ooh, look at me.
You nerd.
Yeah, I'm a nerd. That's how I roll. Anyway, so I did that and I was like, okay, so clearly foam is way too buoyant to make this, because there's no way, if it can't get up in the air, or is having a hard time getting it in the air at 300 grams or 400 grams, or even if it's a half a kilogram,
Right.
it was too much. And adding 3 kilograms to that just so it could sink when it gets to the water is like, nah, that's not gonna work.
I mean, you could do the Subnautica build in that and just put like.
I'd still need the 3 kilograms to get it to sink below.
Well, yeah, but you do it with water
That's the buoyancy of the foam itself. That's not any cavities inside that.
Well, I know, but if you find a way to get it half submerged, or if you could. Hey,
I was basically setting it up so that at least the fuse would be in and the wings would be submerged. But once they were there, it started to become really unstable. Like the cans, I was having a hard time balancing the cans on there. So I know I will probably have like the wingtips will be somewhat buoyant, will be more buoyant than the main fuse probably. So that way the wingtips are at least, I'll call it an inertially stabilizing force maybe.
Okay.
But what it comes down to is foam is too buoyant, which I kind of knew. But I wanted to see, and so what I'll have to do is I'll have to find a material that's far closer to the density of water. And so I'm going to start with sign material, the sign board, the chloroplast.
Mm-hmm.
And the other option is to basically 3D print it and just have water relief holes and see what I can do with that. But I mean, but the whole point of that was to get more information on what direction this project needed to take if I wanted to turn it into the fully functioning, but essentially to achieve all 3 objectives that I had, which was make it look like the sub, which I've done, get it to fly and land on the water, and then the third was to sink it. And have it go around like a sub so that I can then shoot torpedoes. That's,
pew pew.
Yeah, pew pew.
RC torpedoes.
I'll tell you, they've got them. There's a couple people who have some ideas on how to get that. Well, you can do it with a CO2 cartridge, right? The problem is that just goes.
That is going to move.
It's going to move, and I mean, you're not getting that back.
No,
I mean, there's just no way. And there's another way is to basically I use a small controller to allow current to go to basically a little brush scan motor, like an 8020 with a little tiny prop behind it, and just let that scoot across the water. And then
oh man, and that one you could drive with just a capacitor rather than a proper battery.
Pretty much, yeah. Exactly. And you just have like a magnetic switch. So basically once you release the thing, it activates the magnetic. So when it's magnetically attached, it's open. And then when you release the magnet, it closes the circuit. So then it would activate the whole system and it would take off. And then you always, one of the tips is to basically have it set up so that it will always turn a little bit. So eventually it makes a big circuit back to you.
Right. Okay.
So you're more likely to actually retrieve it. And also make it bright colored so you can see it. I mean, if you're looking to retrieve them, otherwise you plan on just making those sacrificial. So anyway, so that was my adventures in RC for the most part this week. I've done a lot of little tinkering that really didn't amount to much. Otherwise.
Okay. And I know looks like you got a couple things else you want to talk about, but I want to rewind for just a second to the Corsair.
Okay.
I'm sorry.
Please.
I know I'm stomping on your ground now.
No, you're not.
But I commented that my elevator and rudder servos kept popping loose.
Yeah.
It was a mixture, I think, because I had the servo pop loose of the glue before, but now the glue was coming loose of the foam. And I forgot the whole inside of that plane, there's no inside paper.
Right.
It's all just bare foam.
Yeah.
And so my glue gun gets extremely hot. And I don't go light when I glue my servos in.
Right.
So I think I may have been melting and really weakening the foam when I was gluing my servos in.
Right. Possibly.
Because it was pulling off the foam too. Generally.
Oh yeah.
So what I've done is I've gone in, cut strips of foam board, glued those in real good to the foam inside the fuselage.
Okay.
So that I've got foam board with paper on both sides. That's being glued as a longer strip inside the fuselage, and then I'm gluing my servo to that foam board. Hopefully, then what I'm doing is spreading the stress of the servo across more.
Right. Yeah. When you're trying to actuate the servo, it's ultimately
right.
rotating the body against the inside of the plane, and there's not enough material to catch it. It overpowers the material you currently have. So yeah, adding a longer strip to distribute that load would definitely help. It's a good solution.
Yeah, exactly. It's taking a 1 by 1 inch, 1 inch by 1 inch square that servo was trying to act on, and now spreading it.
Nice.
So
well, good.
We'll see if that works better.
I hope it will. Another way you can do it is actually make like a perpendicular piece that actually has a notch. So it's like a mechanical coupling too. That's if it gets crazy. But I think what you've done will probably work. So keep us posted if it works. Let us know. It's a good
solution.
Back to yours. No, that's fine. And I was also going to say, I know some people are curious to see how the pilot training is going on. It's been a month. I look back. So I got a logbook and a headset. In the meantime, my own headset. It's my very own.
Your very own.
Yeah. Well, I mean, you have the microphone and the noise canceling ear things. I mean, it's really important. It's just awful loud otherwise. Anyway, so I got those, and we started going back through the logs, and I realized last time I had flown was before Flight Fest, which was like on the 6th or 7th or something like that. And it had been like a full month since I had flown previously. And I was like, oh, geez, that's actually been a while. And, a lot had happened. We went to Flight Fest, and then I had Dad's Stravaganza week with my kids. So where I basically grabbed them from... borrowed them from their mother for a week, and we went up, visited family, and then did all sorts of fun things for a week. We went up to Connecticut and visited New York City, and went to a zoo, did a whole those indoor rope courses. They're like 6-7 stories tall, like it's absolutely crazy.
Good night.
Oh yeah, it was terrifying.
I mean, I'm familiar with outside cope courses, but not the inside ones.
It's essentially the same thing, but they have like an overhead structural piece that your support or safety harness attaches to, and it doesn't come out until you get to the bottom again. Like you're in, but it allows flexibility. So it's a neat system actually. So there was zip lining and all that kind of stuff. Is crazy. I don't know. And we went to and I'll talk about it. So. I'll talk about it in a minute, but we went, part of it was to go to the New England Air Museum, over near Bradley International Airport in Connecticut. You'll probably have heard about it recently. There was, I believe, an old B-24 bomber that accidentally crashed into a hangar. And I mean, if I recall right, it was deadly. There were definitely injuries, if not, it was a horrible accident really. And a terrible loss to the aviation industry. So anyway, so we did that, and then it had been a month since I went back up and flew. So the first time I went back, it was pretty much a refresher. We did a little bit of radio work, which terrifies me. Every time we get on the radio, I'm like, because you want to have it be concise, right? You don't want to be on there like it's like a CB radio, basically. Like when you hit the button to start talking, you are the show for that moment, and you're blocking everybody else. So it's like, oh, gotta do it right. Anyway, and I forgot the whole, like what we call the pattern, stupid, which is, the crosswind, the downwind, the bass and the final. I mean, it's not that hard, but my brain was just like, I don't know what we're doing here.
Yeah.
What do we call this stuff? You have to talk about it on the radio. I don't know.
Well, you're knocking the rust off. The good news is, in my experience, if you've been at something for a while, you take a break, you come back, and you're like, I have no clue what I'm doing.
Yeah, it comes
and then
back.
you get back into it. If you then end up having to take another break and you come back, that time you don't forget.
Okay. Well,
is it my experience with other things, not
Sure.
necessarily this.
Sure. And it wasn't bad. I mean, it was a refresher on some of the things. And it turns out I was able to coordinate the rudder better than I had when I was first doing it. So, it wasn't as good as the last time I was up, but it was still pretty decent. So I was happy about that. And then I went up again, and we just did, the ceiling was really low. So the clouds were basically, it was marginal. So, and it was changing, as the day was heating up, the cloud level was increasing in height and all that kind of stuff. But when we started, we're both looking at it like, I don't know, man, we might be able to get to 1,000 and we'll be kind of at the limit of where we need to be with the clouds. So, and he says, we'll do some pattern work. And if we have to, we'll come back down, So, and that's pretty much what we did. We just drove around the pattern and I practiced doing the radio, which adds another level of complexity to, what feels like a ton of stuff. And ultimately I'm probably overthinking it and, overdoing it, but that's the nature of learning, I guess. So anyway, but it was fun. It was good. I felt a lot more confident, and we did probably 7 or 8 landings, I think. Just touch and goes, coming down, doing the procedure, talking to things. Oh, and then one of the times we were going up, as I'm climbing to 500 on the takeoff, as I'm coming around the crosswind left leg, I look out in front of us, because that's, as you're doing that, you're kind of looking around to see if anybody else is out there, to see if you're getting into any traffic. And below us, kind of scraping across the treetops, was a helicopter. Which, I mean, that's, for us, it's like within 100 feet. And for aviation, that's pretty darn close. It's a lot closer than anybody wants you to be. I'm like, whoa. And meanwhile, you got, we didn't hear anything on the radio. So, instructor's looking around and he's like, oh, just keep doing the pattern. But in the meantime, and he's calling out the radio stuff, because I'm frazzled at that point, going like, what in the world is all going on? He's busy looking, and, in short order, it really wasn't anything. It was probably either a survey helicopter, just, somebody's going from here to there, and they weren't even thinking that, I guess they needed to let everybody know they were there, which seems odd. Maybe thinking that they're so close to the tree line, they're not even really hardly in airspace.
Yeah, they're not remotely going to be an interference for you.
Yeah, but see, like, they're at the end of the runway. So basically what we do is, when we take off to the airport, when we get to the power lines that this thing was kind of flying along, that's where we take our crosswind leg. So that's our turn point. So we're still taking off still. I mean, we're as low as you kind of are going to get from an airport at that point. So, yeah, I think if he's on the other, I don't know, if he's in a different direction, if he was on the downwind leg on one side or the other, it might have been it felt a little bit more acceptable. But whatever. It's what it was. It's in the past. Nobody got hurt, and everything was generally okay. So, so that was the big exciting part of doing the pattern work. But, I've been getting some of the stalls a little bit better, and the landings, they're getting more familiar. So it's fun.
Okay.
And I think I've got another day tomorrow, and maybe one more before I pick up the boys, and then I don't know when I'll be able to get out. So we'll see. I'll be trying to work with some of my friends to see if I can get a couple hours here and a couple hours there. Well, we'll see. In the meantime, let's go talk about some RC.
Yeah. So it looks like you're trying to plan a build night coming up in September.
Yes. Yeah. Cause we try to get something going at least once a month. The last one was a lot of fun. Small group of us kind of talking about all the different things we we're going to do and some ideas we had. And, it was one of the guys was talking about an air coupe, which is an interesting little bird. And I happen to have one at the airport that I fly at. I do the piloting stuff from. So I took a bunch of pictures for him, and he's like, "Oh, that's awesome. That's a big help." Because I could get right up to it. It's not like it's in a museum or anything. So, Yeah, so the next one's going to be on September 17th from 8 to 11 Eastern. I think it's still daylight time. I can't remember when the
whatever. Well,
it's daylight
I would
time.
say whatever, but now, yeah, it also occurs to me that when we are or are not, then sometimes we're 2 or 3 hours, depending on which other time zones are or are not. So,
right, it's daylight savings time still. I think we changed that in October or November. So, yep, it'll be 8 to 11 Eastern Daylight Time. We'll post it in Facebook, so keep an eye out there, especially if anything changes. We might, if something comes up, we might need to change it. But for the most part, just look for it then. Come on out, bring us to your build table, and let's all have a chat while we build a bunch of things that fly.
heck yeah.
Yeah. All right. So I guess that brings us to the first of our topics.
Okay.
I wanted to take a quick minute to talk about going to an air museum, I guess. When I was up on my dad's Stravaganza week, we went to the New England Air Museum. It's right at Bradley International Airport, which is BDL. And you can, and what I'm going to encourage listeners to do, if you can, if you're not like driving somewhere, and maybe you can get to an airport, internet access, or maybe look it up on your phone, go to neam.org, and that's a New England Air Museum .org. And go to the collections tab or collections subgroup, and then I'll have aircraft. Click on there because I'm going to talk about the aircraft that I saw there fairly quickly. But that's a good place to go look at what I'm talking about. I got
mine pulled up.
Good. Me too. And I'm going to briefly describe what it kind of looks like, but I'm not going to do it justice. Go take a look. If you have to, go open this up when you have time. If you're in a car, go back to it and just take a quick look. And hopefully you'll see why I found some of these pretty interesting. But basically, you get in there it's in an old set of hangars outside the airport. So clearly it was this area is just outside the airport fence. It's the perimeter road, and there's a bunch of, hangar spaces and stuff like that all around for various companies. And, it's like an industrial park. So, but in there they have probably about 4 or 5 hangars, 3 of which are open to the museum. And so, I'm sure they're working on a bunch of other stuff in the other hangars. But when you walk in, the whole ceiling is covered in scale models. It seems well done scale models of every plane you can imagine. And so, I don't know.
So what? Just a bunch of, I guess, not RC, but you're saying scale. So they're like...
Yeah, like plastic models.
Okay.
You just hang it almost like you would.
Struggling with that.
Well, it's just like you would have as when you're a kid and you're building plastic models. What do you do when you're done? Well, you hang them from your ceiling, of course.
Okay, all right, well, all right, I got you.
And I don't know if they have. They might. I don't know if they have where they would have that on their website, but it's all over the place. Just literally covering the whole 150 feet of ceiling. It's just planes galore. Everyone you can think of, it's in there. If they made a model of it, it's probably up there somewhere. So it's pretty neat because the ones you didn't see in real life, you could come out to that lobby and kind of look for it because it was up there somewhere. So it's pretty cool. It's neat to see them, and I was curious to see how my kids would what they would think of that. Ultimately, they looked up and they thought it was pretty neat, but they didn't. They're not enamored with.
Okay.
Yeah, they're like, oh, okay, whatever, Dad. One of the things that's interesting about Connecticut is the home to some of the Bell, Pratt and Whitney, and Sikorsky. Those main companies, and they do a lot in the aerospace industry. Sikorsky very much in the helicopters, Bell as well a little bit, but the Pratt and Whitney is the engines, along with a couple of manufacturers. And I know I'm missing a lot of this because, again, I was with my kids. So when I was looking at things, I didn't take as much time as I like to kind of sit and read and understand the details of what I'm looking at. So I was kind of like, oh, cool. I'll take a picture of that and read that later. and I haven't really taken the time to sit down and read some of this stuff. But one of the things, they had a really interesting eclectic collection of very iconic craft and some very unusual things, but were very important to rotorcraft or important to just the history of aviation. And what they do is they'd find a plane and they restore it. And except for one plane in this place, the group that is the museum restores all of these planes themselves. So they've done a ton of work. There's an amazing collection. And sometimes they'll show pictures that this thing looks like it was dredged up from the bottom of something, and they've pieced together parts and pieces from other dredged up parts and pieces of the same plane. And they, put them together and restored them lovingly. And you can tell, like, cause they're in great shape. So I want to, this is me taking my hats off to all of the people who participate in aviation restoration projects for museums and otherwise, because it's a lot of work. It's a labor of love. And you can tell just by what condition these planes are in when they're put on display. Because I know that not one of these started that way, well, maybe one or two, but most of them did not. Anyway, so I'm going to go through a couple, like I said. They had, what I found was interesting, because I looked at a Brunelli, Remington Brunelli 2 was a lifting body craft. Brunelli made a lifting body as well. And I guess they found that the drag, it wasn't as efficient as some other things that also had the same kind of cargo capacity. But they had an example of the Brunelli lifting body in the airport, in the second hangar there, which was really cool. It was neat to see it. So it's basically like a giant wing shape with two fuses on the sides and big wings coming off of that.
Okay. I'm looking for it, but I don't see it.
It's not on. That's the one that's not on their website. If you looked at my Facebook
bad.
post, then you'll find it in there somewhere, which is kind of hard to see because I'm trying to think. There's one of the photos. It's in the background clearly, but you have to know what you're looking at to see. Oh, there it is. I'll see if I can point it out to you, Joe, when I find it. They had a giant flying boat, the VS-44A Excambian. That was the one that was not restored by them. It was restored by Sikorsky. And it is massive. I mean, you think, oh, it's a flying boat. Oh, no big deal. Like, they're big planes. This one's a 4-motor Pratt & Whitney twin Wasp engine. Its range was 3,800 miles, which is basically all the way to Japan and back, I think.
Yeah.
From the West Coast of America. And it could go really, really far. Again, there's a whole history that goes with this, but it's on loan from the Pensacola, Florida, apparently. It's just neat. It was really cool to see after doing the boat. I'm still working on the boat challenge, but basically having put forth the boat challenge and seeing all the airplanes that people have posted, like, oh, I'm going to try this plane or this plane. A lot of them are very similar to this plane that I saw. And it's at least 3 stories tall or 4. It's just really big. And the length is 80 feet. The wingspan is 124 feet. So that's almost a third of a football field, a little over.
Yeah.
It's pretty big. So let's see. And I'm breezing over these, but I mean, truth is there's a lot there. Let's see. There was a Corsair.
Yeah, I'm seeing that.
It was kind of tucked in amongst a lot of things. I couldn't get any good pictures or any good angles. But the wings were folded, and I mean, it looked like it was in really good shape. You can actually see in the one. I'm sorry. There's a helicopter that I want to talk about. It's I'm not finding it, of course, because I want to see it. The Cayman. K-225 or the HH-43F Husky. They're both twin blade helicopters, but they're set up kind of like an egg beater, where the one wing kind of rotates over top of the other. And so they kind of go in synchronous offset from each other. Like an egg beater. So they're not running into each other, but it's crazy looking. They're like kind of out at a couple degrees off from each other.
It is, and I'm not seeing a rotor on those.
What do you mean?
A tail rotor.
They don't need them. They're contra-rotating, so they counter the torque.
Well, that's fine, but then how do they yaw and spot?
I think they have an engine out the back, so they probably have like a slight like a directional thrust maybe out the back from the thrust motor, because there's a big engine on the back of it, and I think that produces a little bit of forward thrust, and so I think I don't know a whole lot about this thing. All I know is I'm like, that is the weirdest looking helicopter I think I've ever seen.
Yeah. Like I was kind of familiar or aware of that design. Just I don't know. For some reason, I thought it still needed a tail rotor.
Well, it doesn't need it for torque. Because most helicopters need a tail rotor to counteract the engine torque of the main rotor blade. And this one, because it's contra-rotating, you don't need one at all, which is really cool. I don't know. It's a neat idea. And so they had two of them because they were built in that area. So there was also in the back of this place looked like a very rundown, like they kind of pulled it out and they're going to restore it eventually. But this may be as restored as you can kind of reasonably get. It's a Cayman K-16B, which is it's a boat plane, except it looks like it has no wings. It's just two big motors, kind of like an Osprey, on a wing that's just big enough to hold the motors. And
yeah, I'm looking at it, and that wing does not look big enough.
No, it's an early VTOL. And so what they would do is they rotate that wing 50 degrees up. And then because those engines are massive, and those propellers are way bigger than if it's a regular just propeller for a boat plane, that's bigger than it should be for that size plane. So basically what they did is that would essentially tilt up and act almost like a helicopter and take off in very short distances. And so it would be used as an early VTOL. And I'm pretty sure it is the concept basically reappears in the V-22 Osprey, which is in use today, which actually I see flying outside my house on occasion. They'll have occasional convoys of like 3 or 4 Osprey zooming around town. And you're like, those things are awesome. Well, anyway, so it was a 1962 version of the VTOL. So anyway, that was a pretty cool plane. I'm looking at that going, I think we can make that RC. We should do that.
Probably could.
I know. They had a bunch of helicopters, and I don't know enough about helicopters to really say much about them, except there was a wide variety of helicopters, as to be expected. They had a Hellcat. They had a Wildcat. So the Grumman F6F and the FM2. And they also had the Grumman F-14B Tomcat. I think everybody knows that one.
I had there was a military fiction novel that I read a couple times. I really enjoyed it. It was called Punk's War, and the F-14 Tomcat was in that one.
Oh, you know what? I think I was the guy, the author of that wrote. He's got a YouTube channel, and he talks about. Does he? Yes, it's really good. I'll share a link to you.
Were you familiar with that book?
Only because he talked about how he was on his book tour for that book, and he basically had the government say, no, you can't talk about some of that stuff. Like they were okay with him promoting certain things. Yes. Yep. Ward Carroll.
Really? Okay.
Mm-hmm. It's funny. It's just a small world. Anyway.
Yeah, no kidding. I did not expect you to know about that book.
I didn't either. Yeah, no, and that's the thing is he was working on with those planes and on those aircraft carriers, and he talks about like that's what his channel's kind of about. It's like, what's the difference between what people say and what like really happened, 30 years ago. Anyway, so that plane's in there. So, and if you live under a rock and you don't know, go watch. Oh, now I'm going to blank on it. What's the movie that made the Tomcat famous?
I don't know, Matthew. What is it? Because you gave me a hard time about it earlier. I couldn't remember.
Top Gun.
There it is.
Because the Top Gun program where they were trying to train the best pilots in the world, they would use the Tomcats way back in the day. They also have an Albatross, a Grumman Albatross, which is used typically for Coast Guard rescues and transports. They had a BG. Sorry, wait, I'm going to get that wrong. It's a GB. Sorry. The BGs make Harmony. GBs make race flights. That's the really short, ridiculously large. It's just an engine with a couple wings, just enough to get it up in the air.
It's almost comical looking.
It's ridiculous.
The R1 Super Sportster replica.
Yep. Yeah. And it broke the world speed record at like almost 300 miles an hour in 1932. And then they went to basically go to another race and then also win that race and I think get another speed record. So, yeah. So
I want to point out, because I've been looking through this list, and one of the ones that jumped out at me that I recognized was a UH-1B Iroquois Huey, from Bell Helicopter.
Mm-hmm.
Again, military novel, Chicken Hawk. Mm-hmm. If you ever I think it was by Mason Williams.
Yes.
I think that book was, if I remember the epilogue proper, that was sort of his post-war recovery was to write that book.
Okay.
But the Huey was prominent in that. That was the chopper he was flying. It's a Vietnam War book, but yeah. So actually, if I had been there to be able to walk up to see the Huey, that would have been cool.
Yeah. I wish you could have. They might even have like a 360 view. Some of the planes have like somebody came around and did a 360 view from like a cockpit, or you might be able to get a much closer look at it. They also had a Sky Crane, which, by the way, that rotor blade is massive. That pretty much took up like half of the hangar in that one. Okay, let's see.
I'm looking for it, but I don't know what
what
the manufacturer was.
I want to say it's Sikorsky. It's like the first one. It's Sikorsky aircraft, and it's the eighth one there, the CH-54B.
Oh wow!
It doesn't look like, but basically it's picking up shipping crates.
Yeah. Okay, I got you.
Yeah, I mean it's designed as a workhorse and it's massive. I mean, straight up massive, and it's really just like a cockpit with like a structural frame to go to the back wheels and the back rotor.
Well, to get this, and then we probably ought to move on. Its empty weight was 10 tons. Its gross weight was 23 and a half tons. So this thing had 27, almost 28,000 lifting, 28,000 pounds of lift for it to make use of for picking stuff up and hauling,
which is incredible.
Like nuts.
Yeah, they had. I'm gonna
as a helicopter.
That's straight vertical.
Mm-hmm.
Okay, I'm gonna cover these just really quick. Go to their website, look at more information. There's tons there. They had a hot rodded Mustang, which was really cool to see. They added air inlets for oil cooling, and they shortened the wings so they can go a little faster and that kind of stuff. They had a blimp undercarriage and remains from the Hindenburg, which wasn't much, but there was some, which was cool. I don't think they have all of them, but they had some of it there, which was neat. Let's see. They had the F-1000 Super Sabre, which is a pretty iconic craft, as well as the F-104C Starfighter, which went Mach 2.5 before before they can go faster. So that was pretty cool to see. Those are some sleek looking aircraft.
Mm-hmm.
And again, there's a ton. I mean, it really was chock full of really neat mix of aircraft. That they had some commercial jets, like small commercial jets. They had a drone, like one of the first drones. One of the ones I really want to make as an RC plane is the RC-3CB, which is just basically like a seaplane version of like a Scout, or the FT Explorer kind of deal, but like a seaplane version of it. They had a Thunderbolt. It's just a whole. I mean, it really just a whole slew of stuff. But one of the big things is they had a B. I don't want to get it wrong. B-29. That was literally almost the entire other hangar. And they even had like a balcony, so you could kind of see it in all one view. Because it's a lot of aircraft to take up at once. So, well, anyway, so go take a look at the website. Go to your local museum, see aircraft where you can. Get inspired, build RC, go fly it. With speaking of, that brings us, I guess, to our next topic.
Yeah. So let's say, as an example, you go in there, you see one of these planes that, you're like, man, I love this plane. I love the look of it. I love the history of it. And I don't know of any plans for it, but I've been able to find 3-view planes for this thing.
Mm-hmm.
And you want to build an RC plane. Essentially Leroy's question.
Mm-hmm.
You know, how are you going from, and you've built and designed kind of your own designs. I don't know if you've necessarily pulled them from 3-view, but I think you have. So how do you go about that process of getting from 3-view to flyable RC?
Okay. Well, I think part of it has to do with what kind of RC model you're looking to make, right? Are you looking to make a profile? Like, are you looking to make it look like it does in the sky? You know, because if you're making a profile, it no matter how you're flying, it's going to look about like you want it to look from far away.
Right.
But I mean, it's a simple build, and it'll fly well. And essentially, once it's off the ground, it's going to look just like you want. But when you get on the ground, you'll see it's clearly a profile plane. You know, once it goes away from you, you'll be like, it disappeared. That's because it's essentially a cross flying through the sky. But those are one of the first ways you can basically build your own plane and see if you like it, right? Like if it's making you happy. That's simple enough where you basically take the side view and the plan view, and you scale. The first thing I do is I try to scale it up so that the prop of the plane that I'm pulling from the 3-view matches the prop and motor size that I'm looking for. You know,
okay.
if I'm going to use a 5-inch prop or a 10-inch prop, I'm going to try to size that view up to match that 10-inch prop or the 5-inch prop, whatever it is. And then at that point, I essentially just trace out the outline and mark out where the control surfaces are, and just know that I'm probably going to have to make them bigger. Like same with the tail, especially with the rudder and the elevator, they may have to be a little bit bigger because aerodynamics don't scale. They just don't scale. Wind works, aerodynamics works the same whether you're big or small. So you may have to increase the size of the control surfaces a little bit, but it's not going to affect how it looks in the air. And you can adjust those on the fly. They're really, if you're not quite getting enough control, you can add more. You can actually add more material after you've cut it out, if you even want. So yeah, take side view, cut out that profile, take the plan view.
Hold on a second. Are you saying that if you make your elevator or rudder, say, and then after fact you're like, those aren't big enough to give me the amount of control that I need, you just say cut them out and then hinge in some longer surfaces
or larger
surfaces?
Yeah, make them a little bit bigger area wise, and
then just hinge them in somehow from one of the myriad of hinging techniques we've talked about.
Yeah. If you wanted the quick and dirty way, just put a piece of tape
them,
and then see if that works. And if it works and you like it, then you want something more permanent, and you can go with a more permanent solution. I mean, but tape works really well. especially for foam board planes. Anyway, so and you can make this step so you can kind of do a bend in the wing at the third point, which is going to create lift. You could do it as a straight plate, because a plate at a slightly high alpha, so 3 or 4 degrees alpha flight, will create lift. You could do it that way, or you can make a KFM, a Klein-Fogelman wing type, which is basically a stepped wing. And you basically make another plan of the front half of your plane and put that on top of the plan view, and now you've got a Klein-Fogelman wing.
Yeah.
It's that simple. If you're doing something so flat, just make sure you reinforce it with a barbecue skewer, carbon fiber rod, or something like that, because it's unlikely to be strong enough for any regular spanned aircraft. If it's like 18 inches or less, you'll probably be okay. But if it's more than that, I'd probably put some reinforcing of some sort in.
I was going to say the FT Delta was one of those KFM wings.
Generally works pretty well. Okay, so that's the most basic kind of design. Again, it gets you seeing the plane you want to see up in the air, and you get to fly it around. So,
well, before we move off of that, because I've never built or messed with or held a profiler, or a profile plane. How would you CG that?
Same way you would any other plane. It's going to get lift at basically a third from the leading edge of the wing.
Well, if you're doing a flat wing like that throws off your lift calculations, doesn't it?
Not really. Essentially, the top of the airfoil shape is the natural curve of airflow over a flat body. So you end up getting that flow shape anyway, even though it's a flat plate. So under that shape, it's pretty much dead air or recirculating air. But above it, you have essentially that airfoil shape. And so it is still creating lift at about the third point. It's a good place to start.
Questions for another episode. Go ahead.
It does. It sounds like we have research we might want to do. Anyway.
Yeah, time to revisit that airfoil episode. Oh, boy.
Oh, well, I'm going to make you do all that research. Forget this. Anyway, but my point is, and you can make it like the old Fogey wing, where it's basically a third is tilted downward and the back 2/3 is tilted the other way, just a little bit. So there's an under camber, and those are good for high lift and slow flight. They're easy to make, and all you're really doing is making a score, filling it with a little bit of glue, and just cutting it down maybe 10 degrees. And as long as the front of that is a little bit higher than the back, you're going to have a plane that flies really well. And the only thing you need to do is kind of just make sure that there's a slot in the profile to fit the wing through, or to slide that plan view through. And then, when you're done, glue it. And you should, put some servos, and you can look up a couple of examples. A lot of 3D indoor flyers are essentially big profile planes, really super lightweight profiles. That's it.
One day I would love to make it.
We need to.
Not in the immediate future, but we watched that video of that that ultra lightweight just sitting there kind of almost hovering, but just a couple feet a second. Just real slow.
Mylar carbon fiber planes.
Yeah, like just 90 degrees straight up and just start climbing, unlimited. But anyway. Sorry.
Yeah, well, that'll be, when we do that, that's definitely going to be an episode. Okay. So then there's basically, now you take that to another step, right? You take it to the next step, which is essentially making your fuse, instead of being a single plane, you essentially make a box. And so what you do is you cut 2 top views of the plan of the fuselage and 2 of the side views, and you make that a box. And then you do the plan view, but then you make an extra plan view to basically put over top of it, make it a little bit wider. And what you're going to do is put a spar in there, maybe a 1/4 inch to a 1/2 inch, or even just 1 extra thickness of foam. If you're using foam, what you want to do is have that slight camber to the top of the wing, and have that spar at the third point from the leading edge. And then you basically attach that to your box. either slide it through, or you can attach it on the bottom or the top, depending on where your wing is sit at. And then you can you can attach them with the barbecue skewers and the rubber bands if you want. There's a million different ways to do it, but basically you attach the wing to the fuse, and then essentially you cut out the plan view of the elevator and the plan view and the side view of the rudder separate, and you attach that rudder piece in the middle of the back of your box, and the elevator attaches typically either slides in through a slot, or it's on the bottom of the fuse box or the top of the fuse box. It depends on where it's sitting, and you can just glue it in place. Or then once you kind of have it set the way you want, you can, what oftentimes they'll have slots and tabs. And what that does is it mechanically connects the two pieces as well as using glue.
Mm-hmm.
And that's the advantage. That's why you'll see flight test planes and a lot of other people will do the slot and tab, is because it adds an additional structural piece. Like if you mess up gluing, that mechanical connection will aid you in it failing. And that's essentially why they do that. And then also make sure it aligns right and all that kind of stuff. So, but you don't need all that if you're trying to get a plane to see if it flies or to have fun making a plane you want. But you can do that.
And then I would say, and I'm going to say, even though Matthew, I know you're immediately going to disagree, I want to say that I have no experience like designing and building a plane like that.
Not the way you, not that you realized at the time.
Well, not that I realized at the time, and I still wouldn't necessarily classify it as such, because it was other planes. It was very simple wing design that we're referencing a long time ago when I did that glider.
Go back to episode 2.
Was it that early?
I think it was that early. It was like the second time we hung out or something, you brought it over.
Oh, man.
Built and ready to go, baby. Awesome.
But like, if I were to do it based on what Matthew's talking about, then I would cut out, say, my two sides of the fuselage, my two tops of the fuselage, and of course have your overlap of the paper. So measure out, here's how much I need, to be the top and the bottom of the fuse, but then figure out which side of the fuse, which cuts, which pieces of foam are going to have the paper overhang, so that you can then glue that to the side or the top, so you get that paper strength. And then I'd say don't worry about trying to get that right as one full cut out of a piece of foam board in the first go, where all sides of the fuselage you're cutting out, say like a Fogey fuselage or a Spitfire fuselage or any other fuselage, where you go and you cut them out and then you cut your slots out of the foam to be able to fold it. Build it first, and then you lay that later. Right. You can project that onto the board and figure out here's where that's going to have to be. So as you're drawing up your own plans after you've seen this is the thing that can happen. That's how I would approach it based on what you've been saying.
And that's essentially, that's dead right.
Okay.
The only difference is, so this is the quick and dirty on how to take a 3D view and make it a plane that you want. Honestly, if you watch Numavig, that's essentially, he's using a Depron, and there's no skin, right? There's no gap you have to make. You just basically glue the pieces together. So you can do the same thing with foam board. You're just, if you want to reinforce it after, you can put tape across that. Use the materials you have to your strength. If you want to design a balsa, I can't talk to that. I don't have that experience yet, but I'm not saying we won't cover that later, but it'll be a little bit. So we're strictly talking cutting it out of some sort of sheet foam material.
Yeah, well, that's what the original question was pointing to anyway.
Yeah, I agree. And then so like the next level, so that's I'll call it the second level, right? First is a profile. Second is I'll call it a box fuse and a Clark Y. And a Clark Y is basically a flat bottom with kind of a curved top, right?
Okay.
And then the next one,
even angular in that we do.
Yeah, with kind of grooves so that it folds at certain points. It makes it just simpler. And by keeping the paper on the backside or on both sides of the foam, it makes the wing much stiffer. So it actually adds structural strength, which can be pretty helpful. Know that if, depending on how big you're going, once you get past about, I don't know, like 50 inches or so, you're going to need to go, unless you're going to do something crazy with the spar, you're going to need to put some sort of additional structure past the foam in the center part of the wing so it doesn't fold. Either a piece of wood or a barbecue skewer or something. Just know that once you get past that certain point, you're going to have to at least consider that. But if you're doing, 50 inch or less, you probably won't need to deal with that at all.
Yeah, depends, because Corsair has balsa spars.
They do. Yep.
And that's just because of the wing shape and all is going to help with that. But
yeah,
then
I think that was a big part there.
The duck, I haven't reached the part of the video yet, but I found multiple thin slits of not balsa, but like pine or something that's in there.
Okay.
And I don't know what that's going to be used for yet. Probably part of the pontoon anchoring, but we'll find out.
It might be. It might be. I'm not really familiar with the kit yet. I haven't pulled mine out and taken it apart to see what I had. A lot of times, the FT methods will suggest grab stirrers, also paint sticks. So you're getting like a 1/8 inch thick piece of pine that's maybe 1 inch wide or 3/4 of an inch wide. And they use that basically as the center reinforcement to basically stiffen up those longer wings. And the Sea Duck is a perfect example of that. It's a pretty long wingspan, but it distributes the load of that pretty well, I think.
Well, what they're doing, and I'm sorry for bringing up the wood with the Sea Duck. I realized as I was talking about, I was like, oh, this might be where it is. But the way that the Sea Duck is handling that is it's, remember I tried to do like a multi-layer glued together spar with a glued together box shell. Well, they're doing a 3-sided box. They're doing a 3-sided channel. So a U shape. That's what that's their spar.
Yep.
Yeah, that's their wing spar.
Yep.
Which sets the thickness of the wing, but also
the height of the wing.
The height of the wing, but also then gives that reinforcement because you've got foam glued at 90s and a shape. So
yeah, and so that's the thing is I think everybody assumes that the foam's doing all the work, but there's a lot of the Dollar Tree foam is a composite material. Essentially, you have foam, you have the paper, there's the glue that adheres them together, and then when you're gluing a spar into your wing, the hot glue you're putting down, when it's done, it is another piece of your composite. Because it is a structural piece. It's flexible, but it's still a stiffer piece that's part of your overall structure. So it does, in fact, add not just an adhesion, but it also adds a certain kind of stiffness that you may not think you're getting. Anyway, that's when you're getting into the fine details of it. I guess it can be important, but I mean, for just putting together a plane that you want to just go fly that looks just like the plane, in some form or another, people can look at your plane and go, "Hey, that's a DC-3 or that's a Starfighter," because they can see the plan, they can see the profile, and they know what it is from those things. Right. That's usually what defines a plane to a degree. And then I think the last level is, I'll call it like a 3D molded fuse. That's more like the Master Series stuff, where you're not really doing as much creasing. You're doing a lot of molding of the foam. And I'm not going to get too deep into that, only because there's a lot of detail that goes into that. But I think the basic method that I've seen that seems to work pretty well, and it seems to be holding with most of the planes I've seen that go that direction, is you have a main box in the fuse, And you have basically a lot of the 3 views, they'll have cross sections of the fuselage, and sometimes cross sections of the wing itself. And what they'll do is those fuselage sections, you cut them out and place them along the box as if the box were your fuse, except for maybe the nose. Assume you're going to make a separate nose, and then you place them along that box where they would go scale wise. And then you make your nose to match what you got, and then you can start molding foam or paper, like a poster board, across those formers, and trim it to shape. And then you basically let that come up, and then you use that as your guide to cut out the foam that then molds around the formers. It's a lot more cut, trim, trial and error. And then when they're done, then they go, okay, I have a pattern. When you're done and it's done right, you have a pattern to basically then take that and draw up, or just, now you can make as many of those planes as you want, and you can do it in one cut. You can make one fuse cut and then mold that as you go, kind of deal.
I can't imagine, having built the Corsair, I can't imagine the time and effort and the trial and error that went into figuring out that plan.
Well, so there's
like even of a single piece,
right? And usually, basically, you'll have between the formers is like one foam ring. That's one piece of your fuse, and you add those together and you glue them together, and that becomes your, when it's all said and done, now that's your whole fuse. Now I did that method with the Viking, the S3B Viking, and it turned out beautiful. I mean, like I couldn't be happier with the thing. It turned out great. And all the planes I've tried that with, it's a really good method. It gives structural capacity. So the fuse is solid, one piece. But it allows, like, there's space inside because of the box to put batteries and components and anchor your servos, and there's space in there for you to do stuff with. So that's a pretty good method. And now what I used was CAD, and then I said, well, there's a 15-degree tilt between here and there, and then I took like the leading edges and turned them 15 degrees and made an arc that was the same length as the length of the top of the former that made up that section from point to point. It's really involved, but when I was done, I just printed it out, cut it, and it fell into place. And that's essentially, there's some people who basically build a 3D model, and then they flatten the skin of that 3D model, and they get something very similar. And I'm not going to get into that. That's for somebody else to do. Maybe we can get somebody on to talk about that. But that's another method. But I think the easiest one, if you want to get something fancy, is to cut out the formers, put it along a box that's appropriately fitted, and then use poster board to get that skin. And then it's going to be painstaking, but I think you'll be happy with it. One of the methods I've seen by some of the guys on the forum is that when you're done, you kind of sand it smooth, you use a little bit of lightweight spackle, and then when you're done, the skin it looks great, and you can paint it and it looks almost flawless, even though there might be imperfections in that process that we talked about. But you kind of, I'll call it buffing it out.
Okay.
Anyway, so those are the 3 methods on taking a 3 view and turning them into a plane, depending on what level of detail you're looking for. Do you want it to just look like the plane when it's flying around in the sky? Do you want it to have more shape and structure to it? Kind of like the flight test stuff. I mean, if you look at the old Fogey, it's just 2 sides, a kind of a shaped bottom and a wing. It's.
I wouldn't even call it a shaped bottom.
Well, the tail tapers.
Okay.
You know what I mean? So, like, if you took the plan view, like, the bottom is kind of the plan view, and then the sides are just the sides, and then that's almost it. There's not much more to the old Fogey.
And I would say it's like we're referencing, say, the old Fogey, or earlier we referenced Spitfire, like if I were doing this,
Mhm.
if I were trying to make plans from a 3-view, and I were doing the trial and error, and I make this, and then okay, that works. I'm gonna pull the dimensions, or I'm gonna redo that. And I'm gonna try to actually make some plans out of it for next time, and refine those plans. And I want to get it, instead of being quite so boxy this time, I want to get it a little more tapered. Or like, look at some of the other, if you've built other planes. So the Fogey's got the tapered tail. The Spitfire has some inserts that go into the top of the fuselage that you then use to wrap that poster board around for sort of
it
cockpit.
creates a curved top, even though
Right.
the plane itself is boxy. It uses the former method basically to create a curved top, even though that's not really functional. It's more aesthetics on that plane.
Right. So I would say look at all the different techniques and styles that you've seen in other plans that you built and steal from it.
Yeah, baby.
That's a technique. Use it.
Yeah, and just practice.
To my knowledge, nothing in all this has necessarily been patented. I don't even know if the A-fold, B-fold, C-fold has been patented.
No.
As far as like it's coined, but I don't know that.
No.
If you see a technique that somebody uses, you're like, I think I can incorporate that into my design to make my plans better coming off this 3-view.
Right.
Grab it and use it.
Yeah, exactly. I mean, I think at least the flight test style, based on, I guess when you're listening to the videos and the build videos and just listening to those guys kind of talk about their goal with flight test, it's to get you hooked into the hobby. I mean, really. And if you think that they've come up with all these designs on their own, like they are flight test designs, but the old Fogey looks an awful lot like a Lazy Bee, and this looks an awful lot like this, and the Spitfire is not a new plane, and the Mustang is a Mustang is a Mustang is a Mustang. You can do it a billion different ways.
Sea duck.
Right, and it's like oh no, I can't think of the name. I think it's L38. Shoot, I'm trying to think of what the Sea Duck actually, because that's an actual plane. It's not just from the cartoon. They based it on I want to say it was an L39. Oh shoot, it's not a Condor. That's all that's coming to my mind. So anyway, you'll find it. Anyway, that's not what's important. Well, one of the things I did is also
Conwing L16 seaplane.
L16. That's it. Yep.
It's a modified Conwing.
Yeah, highly.
Now I'm seeing the pictures from the cartoons.
Yeah, of course you are. It's good stuff.
I gotta go back and watch that.
Yeah, you do. It's good stuff. Okay, so moving on from that, if you are looking to design kind of your own thing, right, and you just want some guidelines, because I think so. This is a design for basically a trainer style plane, but I think unless you're doing a delta wing or that kind of stuff, they kind of hold true. I mean, if you're looking for general sizes and shapes of things, you'll find that most planes adhere to this design methodology. And you look at any regular plane, and it basically starts with the wing chord. So basically trying to figure out how deep of a wing, like how long from leading edge to trailing edge you want, right? And then the wingspan is between 5 and 6 times of that. So you have a wing ratio of 5-to-1 or 6-to-1, right? The thickest part of that wing is going to be 1/3 of the chord from the leading edge. Okay, and that's also where the center of gravity is. It's essentially where the center of lift is, and your center of gravity should be there or a little bit forward. When you put in ailerons, if you're going to put in aileron controls, if you have them the full width of the half of the wing, right, because there's one on each half of the wing, they're going to be 1/8 of the chord. Okay, or if they're half of that, the one side of the wing, or basically a quarter of the wingspan, they're going to be twice as wide. So they're going to be 1/4 of the chord. So if you have just the ailerons on the outsides of the wings, they're going to be bigger. But essentially what you're doing is they're the same area.
Okay, so what you're dictating is, yeah, the ailerons regardless need to be a certain size. It's
Right.
are they
A certain
thin and
proportion of,
long, or are
yep.
they okay? So
Yep.
if they're
And
full wing or short or half wing or less.
mhm.
Okay, I got you.
Right. And I mean, I think a lot of that's going to come down to what kind of material are you using? How flexible is it? Can you put like one control on that aileron and actually move the whole thing confidently? Like if it's a piece of wood, probably it's stiff enough. But if you're using
Mm-hmm.
foam board, it might not be. You may want to go with the shorter, fatter aileron, right? So that's really more a material kind of choice there. And then that essentially covers your wing, right? So let's move to the fuse. The fuselage is going to be about 75% of the wingspan. That's the full length. And then the front part of the fuselage is going to be 1 to 1.5 times the chord length. The chord of the wing is going to stick in front of the wing. And about 2 to 3 times is going to be behind it. 2 to 3 times the chord is going to be behind the wing.
Okay.
Fuse height is going to be about 10 to 15% of the fuse length. You can play with that. But I mean, again, these are all guides. And by all means, take these, throw them out the window and do what you want. But if you want something you know should fly, and it'll probably fly pretty well, these ratios work. Horizontal
Mhm.
stabilizer is going to be 1/3 of the wingspan. Okay. And it's going to be about 15 to 20% of the wing area. The elevator is going to be about 1/3 of the horizontal stabilizer. So the ratio of stabilizer to control surface is going to be 3 to 1. Does that make sense? So the actual like elevator piece is going to be a quarter essentially of the
Okay.
overall area of the back horizontal stabilizer. And
All
then the
right.
vertical stabilizer is basically going to be, so it is going to be about 1/3 the size of the horizontal. So it's a little bit smaller than half. So basically it's like if you cut your horizontal stabilizer, your elevator area stuff, if you cut
In
it in
half
half and basically put it up as a fin and
and
a
shave
rudder
some off of it.
and shave a little bit off of it, that's pretty much what you need,
Okay.
you know. Yeah, because it's like 33% of the horizontal stabilizer, so it's a little bit less, and then the rudder is going to be 1/2 to 1/3 of the vertical stabilizer, which is exactly what I talked about.
You know, I remember you were trying to feed all this information to me a year and a half ago.
I know it was getting lost just because
Oh,
you
it
couldn't.
absolutely went in one ear and out the other. Because I was just like,
And yet
he's
you did all this in your first design. You did this.
Poorly, but like you were, but it was just like numbers, and there was
I know.
nothing on paper that you sent me. It was just like, oh yeah, it should be. And you were just rattling this stuff off the top of your head. And I was like, okay, and I'm listening, kind of. Now I'm going to do my thing.
I mean,
so
right,
it's good to have this.
right, and you got to think of the wing chord. It's going to be like a 10 to 1. So the front to back to the thickness is going to be like an 8 to 1 or 10 to 1, like the length to the height, the thickness of it,
Okay.
basically. And then I think the other thing is because of torque and motor aerodynamic precession and a couple other things, you need to put 2 to 3 degrees of down and right thrust. The down basically angles the thrust to go more through the center of mass of the plane, and the right basically counteracts the torque and aerodynamic tendencies of a plane to turn left, which we've talked about in previous episodes. I couldn't tell you where, but I know we have. And you can look it up and they'll probably explain it. You look up a video and it'll actually show it in motion. You know what I mean? It's kind of when I'm a full size and when I'm in the pilot seat and I turn on the motor, like when I throttle up, I have to put in right rudder every time.
Okay.
To compensate that natural tendency for the plane to rotate yaw to the left.
Right. Okay.
Which is all that stuff, all kind of boiled down on the same thing. Last pieces are wing dihedral. It's basically the up angle of the wing from the center to tips are going to be 3 to 6 degrees. And if you have ailerons, you won't need it as much, so you can get away with like the lower end of that. And if you want to have to improve any stall characteristics of the plane, what you're going to do is put a couple degrees of washout, which is basically rotating the outboard wing chord 3 to 5 degrees downward, or the back of the trailing edge up a couple degrees. It's basically turning it a negative angle of attack. And that's what we talked about. That's why the Prandtl D wing works the way it does to a degree. And then and part of why Corsair and Spitfire and some of the other planes have had them, it's to improve stall characteristics. The center will stall out, and the wing on the outside, because it's turned down, is still before the stall angle of attack. So it's still lifting.
I'm following what you're saying, and it took me a second to realize what you were saying.
Maybe you can sum it up better.
I don't know that I can, because now, like, I've been around the Prandtl D, like, I've seen your design, so I understand this, basically, this twist you're putting in the wing. I'm not sure how well that can be communicated via word, other than to say, if you take your wing and you design it, and it's just your standard wing, it's got an angle of attack on it. Okay, it's whatever put it on the plane it is. Couple, yeah. And if as you go towards the wingtips, if you can twist the wing, say forward, the front of the wing down and the back of the wing up, trailing edge up a little bit, so as you induce that negative angle of attack. That's what Matthew's talking about. It's kind of going from whatever the wing is closer to the fuselage, and as you head for the tip, kind of roll that wing.
Roll it forward a little bit. Just a couple degrees, not much.
Right, and that's going to help with that stall tendency. Mm-hmm. And I don't know how else to say that.
So think about it this way. Every wing shape, as long as it's consistent across it will lose lift at the same angle of attack, right? Mm-hmm. In most wings, it's between 12 and 15 degrees. We can talk about details some other day. But basically, let's say you're flying and you're at 15 degrees is your angle of attack for the plane. All of a sudden, the entire wing will lose lift. If the outside is twisted a negative couple degrees, the outside will be at 12 or 10 degrees, which means the center will be at the 15 where it's losing lift, but the outside has still got more room to go. So it's not going to lose its lift. It's still lifting on the outside.
Specifically so you don't get those wingtip stalls.
Exactly. And so what happens is in a normal plane, your plane's going and everything loses lift at the almost at the same time. And I guess the center's still chugging. The outside has nothing to resist it, right? There's a moment of inertia kind of deal going. And so the outside will lose lift too. And whichever one loses it first, whichever side, it's going to drop.
Yeah.
And now you're not only are you out of control, but you have no lift, and you probably have almost no airspeed over the control surfaces, so you don't actually have authority to get out of whatever you're doing. So you just basically, and this is what we practice in the full-size piloting, is basically you let your plane kind of nose down, let it do what it's going to do, and gain speed, which now you have control, because now there's air moving over your control surface. Now you have control back. You wanted to get enough speed where you can actually gain lift again. Once it's there, now you can go back to what you were doing.
And by twisting those wingtips, so that you've got that negative angle of attack when the main section of the wing stalls, the outside of the wings don't stall first. They were still be lifting. So it's going to keep you straight as the plane falls forward in its stall tendency. And
another way to think about it is hold your plane, and assume if it loses lift all at once, you basically hold it by the fuse and see what happens, right? And not like let it balance on your fingers at the fuse. What happens? It's going to tip one way or the other. You won't know, and it'll be kind of chaotic, right? If you hold it by the wingtips, what's going to happen? Because that's lifting force at the wingtips. What happens if you have a finger under each wingtip? Not much, right? You might lose some authority in the tail. That's about it. So that's why it's advantageous to have that little bit of deal. So if you're running into, like, you have a plane that you designed and it's starting to tip stall like crazy, it might be worth putting in some washout. And then seeing if that
Or
helps.
you can do like the Spitfire did and undercamber those wingtips.
Yep, absolutely. And that's what Flight Test does. So by undercambering the wingtips, you create those create more lift than a traditional Clark Y. They just have more drag, so it's not going to be as fast a plane. But at the RC scale, it don't matter. You'll end up having good flying tendencies, which is good. All right, and I think there's one last thing I just want to cover really quick, because this is if you're trying to basically figure out what kind of flyer it's going to be, you figure out how much your wing area is, and that's basically just the overall area. So the chord length times the wingspan, that's your overall thing. And then you basically divide the weight by the wing area and then multiply that to the 1.5 power. That's your cubic wing loading. I'm not going to get into the whys of that. That's not important. You're going to come up with basically a unitless number, and that number is independent of scale. So no matter what size or shape, it basically tells you how your plane will behave as far as like what kind of glide it's going to get. And so basically, if you want a sail plane or a park flyer, like a little light thing that kind of putts around, you're going to a cubic loading will be between 4 to 7. 7 to 9, it's going to be a sport plane or a trainer. So again, this is just so that you can kind of predict what kind of plane you're going to get when you finish your design. You know, if you want a pylon or a scale flyer, the cubic wing loading is going to be upwards up to 13. And then almost double that is going to basically be a ducted fan, which is like a jet where you're just cooking. But those are useful numbers. And again, these are just so that you can kind of predict what you're in for. You know, are you going to get a sail plane? Is it going to glide forever? Or is it going to essentially, when it's not powered, drop like a rock, which is essentially what usually an ADF does.
Okay.
Yeah. I think that brings us to the end of that. And hopefully that gives you enough information to take a stab at it. Because that's really what my goal here is to give you enough information to try it. Go make one. Whatever suits your fancy.
All right. Well, Leroy, if that was helpful and you do attempt to make a plan or build a plane from 3View, be sure to take some pictures and send it to us.
Okay.
So that we can see what you got. We'd love to see that. Matthew, did you share that website earlier? Did you talk about it?
No, I didn't. I'm definitely going to put it in the show notes for sure. And it is rcplanes.online. And then there's a slash for the page, and it's on the design.htm page. You could go to RC Planes and probably click their main header on designs, and it'll bring you there. But basically, this page it goes into the weeds. Like, I'm covering it enough so that you can get your feet wet. If that gets you excited and you want to know more, go to this website. They go into great detail, and they have like a calculator on their page so that you can put in your dimensions, and it'll give you it'll give you the things you're kind of looking for. It'll help you.
Okay.
So if you're wanting to do it, go check it out.
We'll be sure to put that in the show notes.
Absolutely.
So I guess we'll work on wrapping it up. Reminder, September the 17th. That's a Friday, 8 to 11 p.m. Eastern time. We'll be doing another build night. And if you found this episode helpful, or just in general the episodes, kind of following up on the front end of the episodes, share us with some friends. Again, if you're enjoying us, chances are you know somebody else that would enjoy listening in too. As always, feel free to reach out. Oh, I'm wrapping up mighty early. We still got the workbench.
Yeah, man.
I'm so sorry, Matthew.
No, it's okay. That's okay.
Oh, man. I was heading straight for it.
They're all good stuff, though. I mean, it's really important. Like, if you know somebody who would enjoy this podcast, please let them know about it. Aggregators don't always grab it. And people aren't
That's right.
always looking for it at first. And then they go, oh, yeah, that would be nice.
Man, I was.
You were on it, baby.
Yeah, I mean, I was in a rut and I was going.
Nice. Well, so what are you going to work on, Joe?
I am going to. Ooh, boy, that Southern twang came out all of a sudden. My bad.
Nice.
Good night.
That's all right.
It's it's late enough that's happening. So I'm gonna be continuing to work on the Sea Duck. Because I gotta get that.
Okay, sorry. Go ahead.
What are you laughing at?
Just you're like, it's late enough. That's happening. It's about right. It's about right.
All right, recovering from that giggle fit. I'll be I'll be working on the Sea Duck because I'm hoping to have that done by I don't want to try to outline a date, but I've got about a week and a half to get that finished up.
Okay.
If I'm going to have it flying for when I go down just to see somebody that I was interested in flying with.
Yeah.
And then I've still got the HRC7. The wing is built. I hadn't put the wing tips on, and I've still got like fuselage, tail, and all that. So basically just the wing is built.
Okay.
And then eventually I do want to get back to that Depron wing, finish getting it coated and electronics put in and get that in the air.
Nice. Good. Well, I feel like I'm singing the same tale as like you. Like it's like I keep saying the same things, but I guess I get excited with things that drop in and say hello, like the Star Voyager, right? Squirrel. But I'm still working on the car plane. Matter of fact, I have it on the table here. I think I just need. I think last time I looked at it, I'm like, where did I put all my servos? And then I'm like, oh, we went to flight test. I moved everything around. So I've got to figure out where I put my servos, and I'll finish up this car plane so I can see if I can get it in the air. The J1000 needs a truss in the front of its boot and some servos. Again, that's also the servo train there. I need to get that done. And the HRC Texan, T6 Texan is almost ready to fly. So probably by the time we talk next, I'll have maidened it. I'm hoping.
Nice.
And with any luck, I'll have that microfighter, that Parasite microfighter done. And I'll have given that a try. And with any luck, I'll actually have it fly like crazy. It'll be good times. I'll have hopefully good reports for it. But those are the things that are on my bench, and I'm hoping that I can get them off my bench because I have a lot of things I would like to build after that. So good. And yeah, that's it. So why don't we wrap it up? As Joe was saying, definitely can email us at aviationrcnoob@gmail.com. You can reach me at matthew@aviationrcnoob.com and Joe at aviationrcnoob.com. Say hey, go to the Facebook page and say hey. You can also leave us a message on our website. Well, if we get that fixed up.
Yeah, and certainly feel free to. And if you send us something through the contact us form, just send me an email. So either me directly or to the aviationrcnoob@gmail, so that I know that somebody did fill one out, so I can see if maybe that form's not working, and maybe I'll go in and just complete that form myself.
Actually, I have a task for you listeners. Go to the contact page and just send one and send us an email so that we know.
And say hi.
Yeah, and say hi. And then maybe that's all you do is just say hi. That way we can test it and make sure it's working, because I don't want to lose somebody's heartfelt message because that's not working.
I'll fill it out and submit it for us sometime and make sure that's working.
Okay. No. I want our listeners to do it.
Okay, well, sure.
But it's a good plan though. Okay, and then I think that pretty much. And if you're on the Discord, come out, say hey, just show us what you're working on. Send us a picture. Let us know how we're doing.
All right.
I heard putting a 5-star rating and writing a great review on Apple Podcast helps other people see us in the aggregators. So if you think we're doing a good job, please go out and do that. Well, Joe, do you have anything else?
No, I think that's going to be it, buddy.
Okay, bud. All right. Well, like I said, tune in next time, and we'll see you then.
All right. Good night.
Good night. Other than that, I guess we'll see you next time.
All right. Well,
I mean, that's it, right?
That's it. Okay. Good.
Should I just go? All right, Goose. Tell us what's going on there, bud.
Yeah. Right.
No, I don't think I will.
Now, I am familiar with the F-14 Tomcat.
Yeah.
Only in that,
who hasn't seen Top Gun?
It's the Navy fighter for a while. One of the military novels I read, Punk's War. They were an F-14 squadron on a carrier.
Okay.
Just kind of going through that.
You don't remember it from Top Gun?
Were they flying the fort? I guess they were flying the 14 in Top Gun.
That's where everybody fell in love with it. But yeah, no, by all means, talk about something other than Top Gun, because that's quite the easy target. You know what I mean? The fact that there's another story that goes with it, and I know there's plenty of them. So I'm glad that you have one, because I don't have one other than, yeah, it was cool in Top Gun. Yeah, I remember that Nintendo game.